Namaste, my friend, and welcome back to JEE Mathematics with Typical Monk. This is class 6, and today we open one expression and watch an entire toolkit fall out of it. Take a slow breath, because this is the moment permutations and combinations start paying rent. Every coefficient you are about to meet is simply an NCR you already know how to compute. We are going to expand a plus b raised to the power n and discover that the whole expansion obeys just one rule, applied again and again. One idea at a time. Let us begin. So what will you carry home from today's class? First, how to expand a plus b raised to the n Pascal's triangle and the binomial coefficient sitting inside it. Second, the general term tr plus 1, the formula that lets you pull out any single term without writing the whole expansion. Third, the middle term, the term independent of x, and the greatest coefficient. Fourth, the sum of the binomial coefficients, and the sign flip that appears the moment b turns negative. And fifth, the G drills, a worked problem, a match, and a short answer round. Ready? One idea at a time. Let us start with the raw idea. The binomial theorem is simply a shortcut. It expands a plus b raised to the n into a tidy sum of terms, so nobody has to multiply it out by hand 5 or 6 times over. Sarah noticed something lovely early on. Pascal's triangle is not a separate trick at all. Every number in it is a binomial coefficient, NCR, already arranged row by row, waiting to be read off. Here is a fact worth sitting with. An expansion of degree n always has exactly n plus 1 terms, because r runs from 0 all the way to n, and every value of r gives one term. And one more line G loves. Put x equal to 1, and every coefficient in the expansion simply adds up, giving 2 to the power n. Hold onto that, it returns constantly. Now, look at this triangle, because it turns the whole chapter into a picture. 5 rows from n equal to 0 at the top down to n equal to 4. First, the building rule. Every entry is the sum of the 2 entries sitting just above it. Look at the 6 in the bottom row. It comes from 3 plus 3 in the row above. That single rule builds the entire triangle forever. Second, each row is not decoration. Row n gives you the exact coefficients of a plus b raised to the n. Read left to right as r equal to 0, then 1, then 2, all the way to n. Third, every row is symmetric. NC always equals NC, n minus r. David likes to say, the triangle has a mirror running straight down its middle. And fourth, add up an entire row, and you always land on 2 to the power n, the bottom row here. 1 plus 4 plus 6 plus 4 plus 1 is exactly 16. And 16 is 2 to the power 4. Now, we replace the whole triangle with one formula. The general term, spoken as tr plus 1, equals ncr times a raised to the power n minus r times b raised to the power r. Lisa's shortcut, write the coefficient first, then let the power of a fall as r climbs, while the power of b climbs to match. Second, the middle term, if n is even there, is exactly one middle term. And if n is odd, there are 2 middle terms sharing the peak. Third, to find a term independent of x, you write the general term, collect every power of x into one exponent, set that exponent to 0, and solve for r. And fourth, the greatest binomial coefficient always belongs to the middle term, or ties between the 2 middle terms when n is odd. The triangle is tallest exactly in its center. Let us solve a complete problem together. Slowly, the monk's way. Find the term independent of x in the expansion of x plus 1 over x squared, the whole bracket raised to the power 12. Step 1. Write down what is given. We are expanding x plus 1 over x squared 12 times, and we want the one term where every x cancels away. Step 2. Write the general term, tr plus 1 equals 12cr times x raised to the power 12 minus r times x raised to the power minus 2r, and combining those exponents, the power of x is 12 minus 3r. Step 3. for the term to be independent of x, that whole exponent must vanish. So 12 minus 3, r equals 0. Step 4. Solve for r. 3r equals 12, so r equals 4, which means this is the fifth term, t5. Step 5. The value. The term independent of x is 12c4, and 12c4 works out to 495. Notice the path, given, general term, set the exponent, solve for r, then the value. The same 4 steps open every term independent of x question G can ask. Now let us look inside the formula itself, and then at what happens in the middle of the row. On the left, the general term is broken into its pieces. On the right, 2 small strips of terms, one for even n, one for odd n. First, tr plus 1 is the r plus 1 term. John's rule of thumb is that the term number is always one step ahead of r, so the fifth term means r equals 4, never 5. Second, the powers of nb always add back up to n minus r plus r is simply n every single time. Third, when n is even, there is exactly one middle term sitting at r equal to n over 2. And fourth, when n is odd, there are 2 middle terms at r equal to n minus 1 over 2 and r equal to n plus 1 over 2. The peak splits evenly across 2 neighbors. Now sit up straight. These 5 lines are what G actually asks year after year. 1. If a question calls for the pth term, remember that r equals p minus 1 inside tr plus 1. Miss that one step and every later number is wrong. 2. In a minus b raised to the n, the sign alternates. The term at index r carries a factor of minus 1 raised to the power r, so every odd r term turns negative. 3. For term independent of x or greatest coefficient questions, always write the general term first, then apply whatever condition the question gives you. Never guess the term directly. 4. Putting x equal to 1 hands you the sum of every binomial coefficient in one move, 2 to the power n. 5. The greatest binomial coefficient always sits at the middle term, or is shared by the 2 middle terms. It is never at either end of the row. Let us drill the G way. I read a claim, you decide true or false, and if it is false, find exactly where the reasoning breaks. First claim, every term in the expansion of a minus b raised to the n is positive. Let us check. Each term carries a factor of minus 1 raised to the power r, and that factor is negative whenever r is odd. So this is false. The odd index terms come out negative. Second claim, the fifth term of an expansion corresponds to r equal to 5. Think again. Tr plus 1 is the r plus 1th term. So the fifth term needs r plus 1 equal to 5, which gives r equal to 4. This is false. The fifth term is t5, and that means r equals 4, not 5. Third claim, c0 plus c1 plus, and so on, up to cn, equals 2 to the power n. Check the rule. Putting x equal to 1 into 1 plus x raised to the n turns every coefficient into a plain sum on one side and 2 to the power n on the other. This one is true, exactly as stated. A quick match now. Say each answer aloud before I reveal it. The number of terms in a plus b raised to the power 10. That is 11, because r runs from 0 all the way to 10. The sum of coefficients in 1 plus x raised to the power 7. Put x equal to 1 and you get 2 to the power 7, which is 128. The middle term of a plus b raised to the power 8 is even. So there is exactly one middle term, t5. And the middle terms of a plus b raised to the power 9 is odd. So there are 2 middle terms, t5 and t6, sharing the peak. If all 4 came to you before the reveal, the general term is becoming yours. Here is a favorite G format. I read some statements. You silently count how many are correct. Statement 1. The general term of a plus b raised to the n is tr plus 1 equals n times a to the power n minus r times b to the power r. Hold your verdict. Statement 2. ncr equals ncn minus r. Think before you answer. Statement 3. The greatest binomial coefficient always occurs at r equal to n. So, how many are correct? Two statements, the first and the second. The general term formula is exactly right, and the symmetry NC r equals NC n minus r is exactly right too. But the third one false. The greatest coefficient sits at the middle of the row, not at the very end where r equals n. At r equal to n, the coefficient is back down to 1. Two correct statements, 1 and 2. Now let me save you some marks. Two myths that trap thousands of students every year. Myth 1. The RT term is TR. It feels obvious, R is the index, so surely TR is the RT term. But here is the truth. The term number is always R plus 1. The fifth term means R equals 4, and it is written T5, never TR without the shift. Sarah lost marks for exactly this in her first attempt. Myth 2. A minus b raised to the n expands exactly like a plus b, raised to the n just with a minus sign carried along loosely. The truth. The sign genuinely alternates term by term. The factor is minus 1 raised to the power r, so even r terms stay positive and odd. Terms flip negative. You cannot just wave the sign through without tracking r. Time to test yourself, rapid fire. Here is the rule. I ask, you answer in your head before the reveal. No pen, no paper, just the ideas you built today. Question 1. How many terms are in the expansion of a plus b raised to the power 12? N plus 1, so 13. Question 2. What is the sum of the coefficients in 1 plus x raised to the power 6? 2 to the power 6, 64. Question 3. Which term is the middle term of a plus b raised to the power 10? 10 is even, so it is the single middle term T6. Question 4. In a minus b raised to the n, is the term at r equal to 3 positive or negative? Minus 1 raised to the power 3 is negative, so the term is negative. And question 5. By symmetry, NC2 equals NC what? NCn minus 2. If you caught all 5, you have truly understood today's class. Let us gather the whole class in one slow breath. A plus b raised to the n expands into n plus 1 terms, and Pascal's triangle hands you every coefficient, NCR, without any extra work. The general term is dr plus 1 equals NCR times a to the power n minus r times b to the power r, and the term number is always r plus 1, never r on its own. The middle term is one term when n is even, and two terms when n is odd. For a term independent of x, write the general term, set its power of x to 0, and solve for r. Putting x equal to 1 gives c0 plus c1 plus all the way to cn equal to 2 to the power n. And next class, we step into matrices and determinants. Matrix algebra, determinants, cofactors, the adjoint, and the inverse. Do not miss it. And so, my friend, you have opened a plus b raised to the n and found an entire toolkit inside it. It may have looked like just a triangle of numbers, but understand this. Every approximation, every series, and later even the binomial distribution in probability leans on the exact formula you built today. Sarah, David, Lisa, and John all once stared at TR plus 1 and felt it was just letters. Now it is a tool in your hand. Be patient with yourself. Tonight, revise the shift between R and the term numbered. Once, slowly, because that one step decides half the marks in this chapter. One idea at a time, you will crack JEE. Of this, I am certain. If this class brought you clarity, subscribe to the channel so the next one finds you. Until then, keep going. I will see you with matrices.